Hello friends, welcome back to our class. My name is Kausalya Krishnamurthy. In today's episode, we are going to learn about pair of linear equations in two variables. So we are going to see the general equation of a straight line, slope, and when we plot these equations on a graph, how does it look, the different types of graph that we get when we plot these two equations. And we will also learn how to check for the type of graph without actually plotting the graph using these equations. And we will also try and solve few examples so that we understand this topic properly. So before starting off with pair of linear equations in two variables, let us see what is the general equation of a straight line. It is ax plus by plus c is equal to 0. Now in this, a, b and c are constants and this x and y are variables. Whenever we have an equation of a straight line, we get the slope or the gradient, which is usually represented by small m, which is minus a by b. Let us consider one example. So if we have a straight line 2x plus 3y minus 7 is equal to 0. So this is an equation of a straight line. So in this case, a is 2, b is 3 and c is minus 7. So using this equation, we can also find slope. So what is slope? Slope m is equal to minus a by b. So here a is 2, so minus 2 divided by b is 3. So slope is minus 2 by 3 in this case where we have this equation 2x plus 3y minus 7 is equal to 0. So whenever we plot this kind of a straight line with this type of equation, we get graph either of these forms, in either of these forms. So this is the first one where the line is increasing. So this is a positive slope. Increasing line, so the slope is positive. Here if you observe in the second one, the line is decreasing, which means this is a negative slope. Here if you observe the third one, this is a horizontal line, which means this is a constant. So in this case, the slope is 0. And in the fourth one, the line is vertical. So here the slope will be minus 1 by 0, which means this is undefined. Here in the second line, what you observe here is a decreasing line. So the slope is negative. So we just solved one example. So if we had to plot that particular equation, then the slope would look like this in the graph. Whenever we have a general equation of a straight line in the form of ax plus by plus c is equal to 0, and if we have the value of a as 0, then the graph will look something like this, because here the equation reduces to by plus c is equal to 0 where slope is 0. In this case, the line is perpendicular to y-axis and parallel to x-axis. Similarly, when the general equation of a straight line ax plus by plus c is equal to 0, in this case if value of b is 0, then this equation reduces to the form ax plus c is equal to 0. So in that case, the graph will look like this, like the fourth one. So here if you see, the slope is minus 1 by 0, which means it is undefined. So in case of a undefined slope, the line is parallel to y-axis and perpendicular to x-axis. Let us take an example. If x is equal to minus 3, how will the graph look like? Let us shift minus 3 to this side. So this will be x plus 3 is equal to 0. Minus 3 when shifted this side, it became plus 3. Now, in this case, this becomes 1 into x plus, we don't have y factor here. So this is 0 into y plus c is 3 is equal to 0. Here a is 1, b is 0 and c is 3. So if the value of b is 0, then it means it's an undefined slope. So the graph will look like this, and x is equal to minus 3 will come somewhere here, this side of the y-axis, because it is in negative. Similarly, let us take one more example. Y is equal to 4. So if we have to write this on a graph, let us shift 4 this side. So this becomes y minus 4 is equal to 0. So how do we write this? There is no x factor. So this becomes 0 into x plus 1 into y minus 4 is equal to 0. Here value of a is 0, value of b is 1 and value of c is minus 4. So here y is equal to 4, which means the graph will look like this one, the third one, where slope is 0. So let us move to pair of linear equations in two variables. Here in this case, consider if we have two equations, two lines, a1x plus b1y plus c1 is equal to 0, and the second line being a2x plus b2y plus c2 is equal to 0. When we plot these two lines on a Cartesian plane, so there is a possibility of getting three different kinds of graph. So I have written that on the board here. So the first one is parallel lines. So here if you observe, the two lines are parallel to each other. So in this case, there would be no solution because the two lines are parallel and they are not intersecting. The second possibility is intersecting lines, which means the two lines are intersecting at one point. So there would be one solution. And the third graph looks like this. This is called coincident lines. Here both the equation represent one line, which means they are coincident on each other or they are overlapping on each other. In this case, there will be infinite solution because the lines are coincident on each other at infinite points. Let us move to our next topic. How do we find out the type of system of pair of linear equations? Now consider we got two general equation of a straight line. The first one is a1x plus b1y plus c1 is equal to 0. The second one is a2x plus b2y plus c2 is equal to 0. Now when we have two straight line equation, how do we find out for the type of pair of linear equation? One is we can plot them on a graph and then find out whether it is intersecting or coincidental or it is parallel line. But it is very time consuming. So we are not going to use that method. So there is another trick to solve this. How is it? By comparing the coefficients of both the equations. If a1 by a2 is not equal to b1 by b2, then we say that the equations or the lines are intersecting, which means there will be one solution and we call the equation of two lines are consistent. Now, the second case is when a1 by a2 is equal to b1 by b2, which is also equal to c1 by c2, then we call it as coincident lines where there would be infinite solutions because the lines are overlapping on each other. So we call those lines of equation as dependent. Now the third case is a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. In this case, the lines are parallel, which means they are not intersecting at any point, which means there would be no solution, and we call those two equations or lines of equation as inconsistent. Let us take an example. Check whether the pair of lines x minus 2y is equal to 7 and 2x plus y is equal to 12 are parallel, intersecting, coincident or none of these. Here we have two equations. The first equation is x minus 2y is equal to 7 and second equation is 2x plus y is equal to 12. How can we write this as? We can write this as 1x minus 2y. Let us shift 7 this side. This becomes minus 7 which is equal to 0. Similarly, if we write the second equation, it will be 2x plus 1y minus 12 is equal to 0. Now, what are the values of constants? a1 is equal to 1, b1 is equal to minus 2 and c1 is equal to minus 7. In this case, a2 is equal to 2, b2 is equal to 1 and c2 is equal to minus 12. Now, how do we compare? By finding out the ratios of constants. So, here a1 by a2 is 1 divided by 2. b1 by b2. b1 is minus 2 and b2 is plus 1. So, minus 2 divided by 1. And c1 by c2. c1 is minus 7. c2 is minus 12. Minus and minus gets cancelled. So, this is 7 divided by 12. If you observe here, a1 by a2 is not equal to b1 by b2. Why? Because this is 1 by 2 and it is not equal to minus 2 by 1. So, in this case, we just learned when a1 by a2 is not equal to b1 by b2, the two lines are intersecting. So, option B is the right answer. The options may not be similar. You may also get whether the lines have one solution, infinite solution, more than one solution or no solution. Or you may also get whether they are dependent or whether coincidental, something like that. So, options may vary but the answer remains the same. When a1 by a2 is not equal to b1 by b2, which means it is intersecting line, which means there will be one solution. Let us see the next example. The pair of equations x is equal to a and y is equal to b graphically represents lines which are, I got 4 options here, parallel, intersecting at b comma a. The third option is coincident and the fourth option is intersecting at a comma b. We learned it in the beginning. Whenever x is equal to a constant, x is equal to a, then the line is parallel to y-axis. And when y is equal to b, then the line is parallel to x-axis. Which means if x and y axis are intersecting, the lines will also intersect. So, they will intersect at points a comma b. Why? Because x is a and y is b. So, the answer is intersecting at a comma b. Option D is the right answer. Let us take one more example. For what value of k do the equations 3x minus y plus 8 is equal to 0 and 6x minus ky is equal to minus 16 represent coincident lines? Here we got 4 options. Option A 1 by 2, option B minus 1 by 2, option C 2, option D minus 2. Here in the question we got 2 equations. The first equation is 3x minus y plus 8 is equal to 0. The second equation is 6x minus ky is equal to minus 16. So, how can we write this as 6x minus ky, we will shift minus 16 this side. So this becomes plus 16 is equal to 0. Now what are the values of constants? A1 is equal to 3 is equal to minus 1. C1 is equal to 8. Here in the case of second equation, value of A2 is 6, B2 is minus k and C2 is plus 16. Now they asked us a question, for what value of k do these equations represent coincident line? So what is the condition for a coincident line? So it should be A1 by A2 is equal to B1 by B2, which should be equal to C1 by C2. So in this condition is when two lines will represent a coincident lines. Here what is A1 by A2? It is 3 divided by 6. B1 by B2 is minus 1 divided by minus k. C1 by C2, it is 8 divided by 16. Now 3 ones are 3, 3 twos are 6. Here minus and minus gets cancelled. 8 ones are 8, 8 twos are 16. So here we have 1 by 2, which is equal to 1 by k, which is equal to 1 by 2. So all these have to be equal, which means the value of k is 2, because here A2 and C2 value is 2. So B2 value should also be 2 in order to have these two lines as coincident lines. So option C, 2 is the right answer. So friends, in today's episode we have learnt about the pair of linear equations in two variables. We have seen the general equation of a straight line, slope, how does different graphs look like, and how to find out the type of graph without plotting it on the graph. And we've also seen few examples based on this topic. I hope you've all understood them. And if you've liked the video, please do hit the like button, share it with your friends, and don't forget to subscribe to our channel. Thank you so much for watching us.